Good morning, everyone. Today is December 9th, I think. December 9th, 2022, and we're finishing up our chapter 5.3. We're warming up this morning with two questions that have to do with adding two polynomials together and subtracting. So it says model them as well as gather like terms. So we're going to first model it. I'm going to draw my first term here, 3x, by drawing not 1, not 2, not 3, but 3 of them. Remember, it's called an x because the length is x, the width is 1, which makes the area of that tile x squared. I should erase these here. There we go. That's 3x minus 4x squared are going to be your x squared tiles, but the negativity of them is going to be the unshaded version. So it's the opposite of 4x squared. And then positive 3 will be your 3 integer chips. Once you have that drawn, you're going to combine it with 5 positive x squareds, which we're going to shade in to represent x squared, but positive. And then a negative 3, which will be your negative 3 integer chips. And because we're adding them, another way to describe adding them is just to gather like terms. So we're going to look first for our highest degree terms. What are our highest degree terms of all the pictures we've drawn? Our x squared tiles. So these 4 negatives and these 4 positive x squared tiles are going to make what number, Maito? Those 4 and those 4 are going to make what number? These 4 here and these 4 here will make 0. Leaving me with just this one here, which we're going to write as 1x squared. 1 coefficients are not necessary. We then have these ones which are combining with nothing, so that's just going to become a positive 3x, or in this case, because we're creating a polynomial, a plus 3x. And this constant of 3 and this constant of negative 3 make 0. So there are people that still do this. There are people that still do this, but don't, because there is no constant. So this trinomial matched with this binomial add up to become that binomial. I know you did, because you're smart. Now if we go back in time really quickly, reverse this all the way. I could have erased it, I suppose, but this is kind of fun. Oh, uh-oh. There we go. If we do it without modeling it, all we have to do is start with identifying like terms. Again, what terms are the highest? There are x squared tiles. Notice how I'm including that negative sign, or that subtraction sign, because we're going to consider that to be a negative 4x squared and a 5x squared. If you're doing this, you can just write your term, which is x squared, and you're going to combine your coefficients. So your coefficients here are negative 4 and positive 5, and that makes what number? 1. Do I want to write that 1? No. You could if you wanted to, but teachers frown upon it because when you don't write it, it does show that you understand that not writing it still implies 1. You have your 3x combined with nothing else. That'll just be plus 3x. And finally, grab a different color highlighter. Your positive 3 and your negative 3 combine from grade 7 math to make 0, and you end up with x squared plus 3x. Now the next one's trickier for modeling. It's the hardest part about this whole unit. It's how to model a subtraction. Start with a box and put your first expression in that box. So positive 5 will be 5 integer chips. Negative 2x will be negative 2 of these. And positive 3x squared will be 1, will be 2, and will be 3. So that is this entire trinomial within that box. And what we're asked to do is remove from that box this trinomial's value. So let's look first at our first term. Here we don't have to worry about the order of our terms necessarily. I want to remove 4 negative x's. Do I have 4 negative x's in there? No, and the only way I can put it in there without changing the value is to consider, oopsie daisy, algebraic 0 pairs. So this x combined with this negative x, we know from experience will make 0. So no matter how many of these I put in here, oh, hang on. That's not infinite cloner. Come on now. That does not change the value, nor does that not change the value. So by putting that in, I now have the ability, oh, actually, you know what? I'm going to put it, hang on one second. I'm going to put it right over here. And I'm going to, watch this, I'm going to flip it. Watch the amazingness of this. Flip it left to right. Why? Because now, if I grab my black pen, I can circle the negative 4x's and I can draw them away. and I can then count that I only have 2x's left, right? So that one's done. I've now removed 4x, negative x's from my picture. I now have to remove 5x squareds. I have 3 of them already, so all I need to do is add of my zeros, add 1, add 2, and now I have 5 positive x squareds I can remove. And finally, I have to remove a negative 1, which means I don't have any in there, so I'm going to add a 0 pair in here. And now that I do so, I can remove my negative 1. Now it gets a little tricky here because it's pretty chaotic looking. What terms are my highest degree terms of all the things inside that box? X squareds. How many are left after I remove what I did? Negative 2x squared, right? So my first term will be negative 2x squared right here. Those two right there. My next term, I'll grab a black one. These are left for my x's, which is a positive 2x. Those are done. And what's left here is 6, a constant of 6. So I'm going to write that as is. So keep in mind when you reorder your terms and when you gather your like terms at the end of your modeling, gather them in descending degree of terms. And that is the answer we need. However, the easiest way for us to get the answer to the subtraction is to do what? Jelly, what do we have to do here? Keeping in mind grade 7, if you use positive 4, take away a negative 3, what was the way you solved that question? You keep flip change, right? So you said this is the same thing as positive 4 plus positive 3, keep flip change, and you solved that question instead, which was 7, right? That same logic applies to polynomials as well. So I'm going to keep this first polynomial as is. I'm not going to change it. I'm going to change, so I'm going to keep that first polynomial. I'm going to change it to addition, and I'm going to use the opposite of this polynomial. So keep flip change. What's the opposite of that polynomial, Danny? What's the opposite of the yellow highlighted polynomial? Positive 4x minus 5x squared plus 1, right? So using our integer ideas of adding the opposite works instead of subtracting, we can do this. Now we're going to gather like terms. Grab my highlighter, highlight my highest degree term of my first polynomial, x squareds, highlight the x squareds of the second term. When I combine, when I write the term, x squared, and if I combine the coefficients of positive 3 and negative 5, I get negative 2. Done. Close. When I take my highlighter and highlight my next highest degree term, negative 2x and positive 4x, I get positive 2x. And finally, when I highlight my constant of 5 and my constant of 1, I get a plus 6 constant. And that's the easiest way to do it. Just add the opposite. So on your test, you will have to demonstrate the ability to model it. Just one question, not a lot of them. But generally speaking, when you're asked to subtract polynomials, you should use adding the opposite.